Okay, today we're looking at Grade 5, Module 5, Lesson 6. To find the total volume of solid figures composed of two non-overlapping rectangular prisms. So as we look in our example, we see that we have, in essence, two rectangular prisms connected to each other. And what we need to do is use the information from one to help us solve for the other. So what I did here is first I'm going to take it and break it up into two smaller figures. Find the volume for each of these smaller figures, and then add the totals together to get the total volume. So starting with figure A, we see we have a length here of 3 inches. Down here, we see a width of 5 inches, and if the width down here is 5 inches, we can conclude that the width here is also 5 inches. And then we see we have a height of 2 inches. So what we are going to get is 3 times 5 times 2, following our volume formula, for a total of 30, not centimeters, but inches cubed. So now let's go ahead and look at figure B. Here's figure B. Here we see that we have a a length of 6 inches. Again, the same width of 5 inches. And now we're told we have a height of 4 inches. So following again our formula, 6, our length, our width, 5, our height, 4, equals 120, again, inches cubed, for a total of 150 inches cubed. Okay, now in this second example, again, I'm going to break my figure up into rectangular prism A and rectangular prism B. And we'll start here trying to decipher length. Well, we know the entire length of the bottom is 6 meters. We know our entire length is 6 meters. We know from this portion to this portion is 4 meters. 6 minus 4 equals 2. That's going to leave my width of my box A at 2 meters. If we come down here, we see the width is 2 meters down here, so we can conclude that the width here is also 2 meters. Finally, we see the height from top to bottom as 4 meters. But if we come to this side, we see that the bottom, figure B, has a height of 2 meters. Well then, 4 meters minus 2 meters means we are left with a height of 2 meters for figure A, giving us a length of 2, a width of 2, and a height of 2, for a total volume of 8 meters cubed. We then look at B. We have an obvious length of 6 meters. We have an obvious depth of 2 meters, and they've given us the height already of 2 meters as well. Following our formula, 6 times 2 times 2, 6 times 2 equals 12, 12 times 2 equals 24. We are left with 24 meters cubed for figure B. Add them up, we have a total volume of 32 meters cubed. Okay, let's take a look at one final word problem. Two rectangular prisms have a combined volume of 135 cubic meters. Prism A has double the volume of prism B. So our two parts we're asked to do is, what is the volume of each prism? And B, if one face of prism A has an area of 10 square meters, what is its height? So, to solve part A, we know that part B is 1 unit. Part A, using a tape diagram, is twice part B. So we have the sum of volume of A plus B equals 135. This gives us 3 equal units. That equals 135. If we divide, we find that 1 unit equals 135 divided by 3 equals 45 meters cubed. Since B equals 1 unit, B equals 45 meters cubed. And A, which equals 2 units, 45 times 2 equals 90, so A equals 90 meters cubed. Part B, we'll refer back to our formula, volume equals area times height. Our volume for part A is 90 meters cubed, and that's going to equal 10, the area they tell us for prism A for one side, times its height. To solve for height, we would do 90 divided by 10, as we are asking ourselves 10 times what equals 90. We solve that by doing 90 divided by 10 equals 9, so our height equals 9 meters.